Good evening. Good evening, children. Good evening to all. Am I audible? Good evening. Good evening, Srangvi. Good evening. Oh, Vaishali entered today. Unfortunate. Sahasran, good evening. Tulasi, good evening. Darsh, good evening. Shambhavi. Tanmay Hiravat. Purvi Kucharlapati. Nikhil. Yeah. We are discussing problems in exercise 2A. Indrani. Roshita. So I told you to do problems from 1 to 12. Is there any doubts in that, children? Problems 1 to 12 in exercise 2A. Purnima. Purna Chandrika. Iti Srimad Bhagavad Gita Su Kirtika Rathod. Any doubts in problems 1 to 12? I will consider one problem which is given in CBSE 2011 examinations. 2 root 3x square minus 5x plus root 3. Find the zeros of 2 root 3x square minus 5x plus root 3. This problem is given in 2011 CBSE examinations. We need to find out the zeros of this polynomial. If you observe the coefficients of this polynomial, the coefficients are real numbers. Okay. First, as it is, multiply the coefficient of x square with x square. Good evening, Ashish. With constant. Coefficient of x square is 2 root 3 and constant is root 3. So multiply them. 2 root 3 into root 3. How much? Root 3 into root 3, how much, Nana? 6. Very good. 2 root 3 into root 3, it is nothing but 2 into 3, which is 6. But in the middle, we need to get negative 5. In the middle we need to get negative 5. So what are the possible values of the factors of 6 whose product is positive 6 and sum is negative 5? Yeah, very good. Sum negative 5 రావాలి అఖిల తమ్మిన sum negative 5 రావాలి, product positive 6 రావాలి. Good evening Arya. Sum is negative 5 and product is positive 6. Very good. So 2 root 3x square minus 2x minus 3x plus root 3. So the middle term is splitted in that way. The middle term negative 5x, we can split it as minus 2x minus 3x. Okay. Now from the first two terms we can take 2x common. 2x common. Remaining is root 3x plus 1. 1 not plus, minus 1. Root 3x minus 1. And in second two terms we can take negative root 3 common. In second two terms we can take negative root 3 common. So remaining is root 3x minus 1. Now again root 3x minus 1 if we take common, remaining is 2x minus root 3. Now zeros of this one is 1 by root 3 and 0 of this one is root 3 by 2. So 1 by root 3, 1 by root 3 and root 3 by 2 are the zeros of the given quadratic polynomial. Okay na children? 1 by root 3 and root 3 by 2 are the zeros of the given quadratic polynomial. So in this way we can find out the zeros of given quadratic polynomial. Now we are going to establish the relation between zeros and coefficients of a quadratic polynomial. See, I am writing here the general form of a quadratic polynomial. Ax square plus bx plus c. Ax square plus bx plus c is the general form of quadratic polynomial. Okay. Now, we know it is having two zeros. We know it is having two zeros. Let us assume alpha comma beta are the zeros of ax square plus bx plus c. Let us assume alpha comma beta are the zeros of ax square plus bx plus c. ఏంటి ఆల్ఫా బీటా ఏంటి? ఆల్ఫా బీటాలు ఏమిటంటే దే ఆర్ గ్రీక్ లెటర్స్. ఇప్పుడు మనకి ఏదైతే ఇంగ్లీష్ లెటర్స్ ఉన్నాయి కదా ఏబిసిడి, ఇన్ ద సేమ్ వే దే ఆర్ గ్రీక్ లెటర్స్. వై we are using Greek letters here? Because for unknown values generally we use x, y, a, b, c like that, na? So to look differently for unknown zeros we'll assume alpha and beta, or we'll assign, not assume, we'll assign alpha and beta, the letters, Greek letters alpha and beta as zeros of the quadratic polynomial. అంతే, ఇది ఎక్కువగా దాన్ని ఊహించుకోమని. ఆల్ఫా ఏంటి? it is an unknown. Beta, it is another unknown. So alpha, beta we are considering as the zeros of ax square plus bx plus c. Okay, unknown zeros for a quadratic polynomial. Okay na? Ante. It's like the unknown values we will consider unknown values as x and y na, or a and b and c. So unknown zeros we will consider as alpha and beta. Quadratic polynomial aithe, cubic polynomial aithe alpha, beta, gamma. Because cubic polynomial is, for a cubic polynomial we can have 3 zeros. Is that right? Every cubic polynomial is having 3 zeros. So those 3 unknown zeros are alpha, beta, gamma. Quadratic, alpha, beta. Linear, alpha. Biquadratic, 4 zeros. Alpha, beta, gamma, delta. Delta. Alpha, beta, gamma, delta. All these are Greek letters. Okay na? Now, let us assume alpha, beta are the zeros of ax square plus bx plus c. Okay. Now, alpha plus beta, alpha minus alpha into beta. Okay, let it be. Since these two are the zeros, x minus alpha, x minus beta are the factors of this polynomial. Alpha, beta are the zeros of ax square plus bx plus c. Then x minus alpha, x minus beta are the factors of ax square plus bx plus c. అనవసరంగా ఏది చెప్తున్నానేమో. ఓకే, ఇదంతా ఓకే రైట్. Alpha, beta are, let us assume alpha, beta are the zeros of a quadratic polynomial. Okay, what relation exists between zeros and coefficients? Right, ax square plus bx plus c. Zeros, coefficients. Alpha, beta are zeros, a, b, c are coefficients. So what relation exists? Sum of zeros and the product of zeros. Sum of zeros and the product of zeros. Yeah. Sum of zeros is same as minus b by a. Sum of zeros is same as minus b by a. And the product of zeros is same as c by a. This is the relation between the zeros and the coefficients of any quadratic polynomial. Sum of zeros is equal to minus b by a and the product of zeros equal to c by a. So these two relations we can observe for any quadratic polynomial. Let us consider an example. Okay, yeah, 3x square minus x minus 4. I am considering a polynomial. Find the zeros. Negative 12. So 3x square minus 4x plus 3x minus 4. Okay. Now if I take x common, remaining is 3x minus 4 plus 1 common, 3x minus 4. So 3x minus 4 into x plus 1. So zeros, alpha is 4 by 3, beta is minus 1. Alpha is 4 by 3, beta is Means we'll get zeros na. 0 of this polynomial is 4 by 3 and 0 of this polynomial is minus 1. So I'll this 0 I will take it as alpha and this one I will take it as beta. Alpha 4 by 3, beta minus 1. Now, as I told you that for any polynomial, for any quadratic polynomial, this relation holds good. I told you that. We'll see that. We'll observe that. Now, what are zeros? What are zeros? 4 by 3 comma minus 1. And what are ABC? What are coefficients? ABC, A3, B negative 1, C negative 4. Okay, na? Now we have the zeros and we have the coefficients. Now, find out alpha plus beta. Find out alpha plus beta. That means 4 by 3 plus negative 1. When we simplify this one, 3 LCM, 4 minus 3. So 1 by 3. Alpha plus beta value is 1 by 3. Now, find out alpha beta. 4 by 3 into minus 1. Minus 4 by 3. So we got alpha plus beta as 1 by 3. Alpha beta as minus 4 by 3. Okay? Now, we verify. Minus b by a. Minus b by a. Minus b by a, which is equal to 1 by 3. Minus b by a, how much we got? 1 by 3. C by a, what is C? Negative 4. What is A? 3. Now see, alpha beta, how much we got? Negative 4 by 3. C by a, how much we got? Negative 4 by 3. So, alpha plus beta, what we got? 1 by 3. Minus b by a, what we got? 1 by 3. So, what we can conclude? Alpha plus beta is equal to minus b by a, and alpha beta equal to c by a. So, that was the relation between zeros and coefficients between of any quadratic polynomial. And it works out. You can take any quadratic polynomial and observe this relation. One more we'll see. One more we'll see. I'm considering this. I'm considering 5x square plus 10x. What are the zeros of 5x square plus 10x? If I take 5x common, x plus 2. So 0 of 5x is 0 and 0 of x plus 2 is negative 2. So zeros are 0 comma negative 2 and A 5, B 10, C 0. Zeros are 0 comma minus 2. Coefficients, A value 5, B value 10. Constant is not there na, so we have to take it as 0. Now, alpha plus beta, 0 plus negative 2, negative 2. Alpha beta, 0 into negative 2, 0. So we got sum of zeros and we got product of zeros. Now, what is minus b by a? What is minus b by a? Minus 10 by 5, which is negative 2. What is c by a? C 0, a 5, 0 by 5, 0. So, what we can observe here? Sum of zeros equal to minus b by a equal to negative 2. Sum of zeros ఎంత వచ్చిందో We got same for minus b by a also. And product of zeros is same as c by a. Product of zeros is same as c by a. Understood, children? Is that understood, or I need to explain one more problem? No one is answering. Am I audible? See, I am not explaining the proof. Sir, how can you know that alpha plus beta is equal to minus b by a? What is the proof for this? If you ask me, what is the proof for alpha plus beta is minus b by a, alpha beta is c by a? If you ask me that, see, it is not necessary for all the students. If any student is interested, you can ask me in the class, or whenever I am free in the school, you can ask me, I will explain you that. Okay, na? How alpha plus beta we are considering minus b by a, and alpha beta we are taking minus c by a. But here we are observing only examples, whether the relation is holds good or not in any quadratic polynomial. We are observing that. Okay, na? So, one more example. Children, now you give a polynomial of your own. We will try to see whether this relation holds good or not. You give a polynomial of your own. You give a quadratic polynomial. There is a proof for this. How alpha plus beta is minus b by a and alpha beta is c by a. What is the proof for it? There is a proof, but it is not necessary for all the people. Okay, na? Now, can anyone give me one quadratic polynomial so that I can verify that this relation holds good or not? Five x square plus 2x minus 8. Okay. 5x square plus 2x minus 8. Okay. We'll see this. Good. Now, 5 into negative 8. 5 into negative 8, negative 40. So multiply cheste negative 40, add cheste positive 2. What are the possibilities? I took one problem, right? I took one problem already, and I am going to solve it. What are the possibilities? 5 into negative 8, negative 40. So we need to search for two numbers whose product is negative 40 and sum is positive 2. Search for two numbers. You search for two numbers whose sum is positive 2 and product is negative 40. No one. Who gave this problem? So negative 40, what are the possibilities? 10 into minus 4 minus 10 into 4. 5 into negative 8 minus 5 into 8. What else? What else? Negative 20 into 2, 20 into negative 2. That's all. But if we observe here, we cannot consider any pair over there. Any pair. So, by using splitting the middle term, we cannot find out the zeros of this polynomial by using splitting the middle term. We cannot find out. Then how can we find out its zeros? It is a different topic. When I'll explain you the quadratic equations topic, then you can find out its zeros. Quadratic equations topic. Now it is not possible over here in polynomials. That's why you gave another polynomial. Give another polynomial, children. Now it is not possible. Whatever the polynomial given by Ashi, we cannot split, we cannot find out the zeros by using the splitting the middle term concept. Understood? So that's why better to give another polynomial, children. Today only 24 are there. Excellent. 3x square plus 2x minus 8. 3x square plus 2x minus 8. Amulya is there in the class? She only not there. I told her to maintain a record. And even Tejal is there in the class? Now, 3 8s are negative 24, negative 24, negative 24, in the middle positive 2x. So 6 into minus 4, 6 into minus 4. So 3x square plus 6x minus 4x minus 8. So 3x I can take common, x plus 2. Minus 4 I can take common, x plus 2. X plus 2 common here again. 3x minus 4. So 0, negative 2. Here 0, 4 by 3. So negative 2, 4 by 3 are zeros. Negative 3, negative 2, 4 by 3 are zeros. And what are the coefficients? 3, 2, negative 8. 3, 2, negative 8. Okay. Now, alpha plus beta minus 2 plus 4 by 3, how much? Minus 6 plus 4 by 3, negative 2 by 3. Alpha beta minus 2 into 4 by 3, negative 8 by 3. So we got alpha plus beta value and alpha beta value. Now, what is minus b by a? Minus b by a, negative 2 by 3. What is c by a? Negative 8 by 3. So automatically alpha plus beta is same as minus b by a. And alpha beta is same as c by a. Okay, children. So like this, whatever the polynomial if we consider, whatever the polynomial we can consider, we can establish the relation. So what is the relation? Sum of zeros means when we add the two zeros, it is equal to minus b by a, and the product of zeros, it is equal to c by a. Sum of zeros, alpha plus beta is minus b by a, and product of zeros c by a. Amulya and Tejal, send the list of students who are absent today. Yeah, there are some polynomials for which splitting the middle term is not possible to find the zeros. Like we have seen one example. For some quadratic polynomials, splitting the middle term is not possible for finding its zeros. So what to do for them? How can we observe the relation? So it will be done in quadratic equation topic. No worry. Okay, na? Vamsi is there, but you are not responding. But in polynomials, whatever the problems are given to you, we can solve them by using the splitting the middle term. We can solve them by using splitting the middle term in polynomial topic. But whereas when we learn these quadratic equations also, then we can find out the zeros of any quadratic equation, whether it is possible by splitting the middle term or there is another method to solve. I'll tell you that time. Okay, na? Okay. So happy Sri Ramanavami. Again we'll meet tomorrow at 8 o'clock. Dhanyawad. Thank you very much. And click on the like button. Click on the like button, then move, then leave the class, children. Thank you. Tejal, you came? Thank you very much. Alright, 27 are joined, only 13 likes. Excellent students. Bye bye.